Okay, what I'm going to do is I'm going to work through the practice competency test with you. I'm going to explain everything that I'm doing so you don't have a problem with it. Now, it's kind of blurry, but unfortunately I can't seem to make it any more clear. Alright, so in the first problem, -3 minus 7 minus -57. So the first thing you're going to do is look and see these two negatives, because two negatives in succession become a positive. Then I'm going to work left to right. -3 minus 7 is -10 plus 57. Then when I get to this point, I look at these two numbers and see that the signs are different, so I'm going to subtract and get 47 and take the sign of the larger number, which is a positive. Alright, this problem is minus parentheses -3 squared. So this tells me that I'm going to be squaring -3. So basically I write down -3 twice, and then I bring this negative sign that's outside the parentheses down. So I have 1, 2, 3 negatives, so an odd number of negatives mean a negative. The other way to look at it is think about having pairs. I have a pair and one left over if I have 3 negatives. So that means that anytime I don't have pairs, if I had 4 negatives, I have 2 pairs. So those would both be positive. But since I only have 3, I have that odd one, so that makes it negative. And then 3 times 3 is 9. Alright, the third problem is 2 times -6 plus 3. So the first thing I'm going to do is order of operations. I'm going to do the multiplication first. So 2 times 6 is 12, and it's a -6, so that means I've got one negative there, so that makes it -12 plus 3. Then the signs are different here, so I'm going to subtract. 12 minus 3 is 9. Sign of the big number is negative, so my answer is negative. Alright, in the next problem I have -81 and +5. Signs are different, so I subtract and get 76. Big sign of the big number is negative, so my answer is negative. Alright, in the next one, -8 plus 2 times 6, -8 minus 2 times 6. So the first thing we're going to do is that 2 times 6, which is 12. I bring my negative down and then write down my -8. Then I have a -8 and a -12. The signs are the same. That's like -8 plus -12, but if you just think of the sign in front of the number as the sign of the number, the signs are the same here, so we're going to add and get 20. Answer's negative. Sign of the big number. Alright, in this one I have 2 multiplications, and then I subtract. So 5 times 3 is 15. 2 times 9 is 18, and then 15 minus 18. Again, signs are different. Subtract and get 3. Big number's negative. Okay, in this one, I have this multiplication piece in the middle of the problem, so I'm going to do that first. So I bring my 14 down, my negative sign down. 8 times 2 is 16, and then I deal with these two negatives here, which make a positive. So once I get to that, I could have done 14 minus 18 is negative, 14 minus 16 is -2. -2 times +2 is 0. Or -2 and +2 is 0. But remember, I can group any way I want to. So I look at this and say, well, 14 and 2 give me 16. So if I group those two together, then 16 minus 16 is 0. So that's much quicker. Okay, this problem, I'm doing fractions. So I've got a 5 and a 3. When I add and subtract fractions, I have to have a common denominator. When I multiply and divide, I don't. So I add and subtract. So my denominator for 5 and 3, these numbers don't have anything. Multiples of 5 would be 5, 10, 15, and so forth. Multiples of 3 would be 3, 6, 9, 12, 15. So the smallest number that I have would be 15. But now keep in mind, if you're doing this on a test, you don't have to find the smallest. You can always find a multiple by multiplying the denominators. So if I multiply 5 times 3, I get 15. Now, to figure out what goes on top of 15, you know there's always the rule where you cross multiply and then that goes on top. But I always do it this way because this is how you need to teach children how to do it. So, I need a denominator of 15. So then I have, what I'm actually going to do when I'm solving this problem then would be to write this down like this. 1/5 times something equals 15 on the bottom. And then if I look at that, 5 times what's 15? It'll be 3. So I have to, if I multiply, I want to find an equivalent fraction with the denominator that's 15. So whatever this number is, it's going to be the same as 1/5. It's just going to have a different denominator. So in order to do that, I can multiply by 1, I can divide by 1. Now in this case, 1 in the form of 3 over 3. So then 1 times 3 is 3 and 5 times 3 is 15. Now I'll redo the bottom one the same way. I have 2/3 times something equals 15. See, all I do is start with my original fraction multiplied by my little bar equals, and then whatever my denominator is. 3 times what is 15? That'd be 5. See, I just divide the two. Then I multiply the top. These two have to be exactly the same thing. So that's where that comes from. Alright, then I'm going to add these two fractions together. Once the denominators are the same, I add my numerator. So 10 plus 3 is 13. So my answer is 13 over 15. Okay, in my next problem I'm subtracting. So I've got 5 and 4, so my denominator is 20. I do exactly the same thing as I did before. 5 times 4 is 20, so I multiply by 4 over 4. 4 times 4 is 16. Excuse me. Then 4 times 5 is 20, so I multiply by 5 over 5. So I have 5 over 20. 16 minus 5 is 11. 11 over 20 is my answer, and it won't reduce. Okay, my next problem is, let's see. Here we go. Negative 7/5 minus negative 3/5. So the first thing I'm going to do is take care of that negative sign. The two negatives there, side by side, mean a positive. Or the opposite of a negative, if you want to think of it as that. So the denominators are already the same. So you could think of it like this. Negative 7 plus 3 over 5. It's the same concept. Any way I go about it, negative 7 and positive 3 is going to be negative 4 over 5. Now keep in mind, you can write a negative 4 over 5. You can write negative 4/5 like I have, or you could do 4 over negative 5. Those are all three exactly the same answer and would all be correct. Okay, number 11. Negative 18 over 1 times negative 5 over 6. I'm going to do this two ways. So I could just multiply across the top. 18 times 5 is 90, and I have two negatives. That's a pair, so that means that's going to be positive. So 90 divided by 6 then is 15. Now, this is the easiest way to do it because then I don't have to deal with large numbers. Alright, I'm going to rewrite this problem down. Negative 18 over 1 times negative 5 over 6. Okay? So then 6 into 18 is 3. Then across the top, the numerator will be 3 times 5 is 15. Okay, and I have a pair of negatives, so that makes it positive. Now, when I do this, I divide 6 into 6 is 1, so that I always forget to say that whenever I do it. So then 15 over 1 is just plain old 15. Okay, and then this problem is the same thing, only I'm doing a shortcut here. And let me show you what I did so you can see. Okay, I have negative 2/3 plus 1/2 minus 5/7. It's easier to see if I write it this way. Okay, so what I did is I said, okay, the first thing I need is a denominator. Doesn't have to worry about what one is. I multiplied the 3 together. So 3 times 2 is 6, 6 times 7 is 42. So that's going to be my denominator. Okay? All right. Now, 3 times what is 42? Now, here's the trick. It'll be it'll be the other two numbers multiplied together. So, in other words, I divide 3 into 42, but my answer is really the same thing as this. Both. So all I'm going to do is write it up here, because that means I have to multiply, because I would be multiplying by 14 over 14. So like when you had this fraction piece like this, that 14 over 14 would be there. But I'm doing it shortcut, I call it, so I don't have to use so much paper. So then 2 times 14 is 28. Then 2 into 42 would be 3 times 7, which is 21. So then I would multiply by 21 over 21. And, excuse me, and that gives me 21. And then 7 times what's 42, and that would be 6. So then I multiply by 6, both of them. So I end up with this. Okay, which is what I have here. All right, I have negative 28 plus 21 minus 30. Now here's what I did first. I looked at this and said, a lot of people will do in order left to right, and that's okay. But I just always put all the negatives together so that if I had a big string of numbers like this, okay, I would make a list of my negatives, make a list of my positives, add them up, and then I'll have a negative number here and a positive number here, so then I'd subtract in the end. That makes it easier, I think. Okay, so let's go back over here to our problem that we had. All right, so I have, oh, here it is. So I have I added these two together because they're both negative and got negative 58. And then bring down my 21, and I just put them all over 42. It's the same thing. Then signs are different here in the numerator, so I subtract and get 37 over 42, and I see a mistake. I forgot to bring down my sign because it's always the sign of the bigger number. So it's negative 37 over 42. Okay. Now on this one I'm doing the shortcut method. I put 15 over 1. Then 3 into 3 is 1. 3 into 15 is 5. And then multiply across the top. 5 times 5 is 25. It's going to be over 1, but that's always understood. It would just be 25. Excuse me, it is negative. Okay, number 14. This says negative 2/5 cubed. So that means write it down 3 times and multiply it together. So I've got negative 2/5 times negative 2/5 times negative 2/5. So across the top, 2 times 2 is 4 times 2 is 8. 5 times 5 is 25 times 5 is 125. It won't reduce. Don't have a pair of negatives. I have that one odd one left over, so that makes it negative. Okay, and the last one, I have multiplication to do first. So I go ahead and multiply. 5 times 2 is 10, and 8 times 15 is 120. So I've got 1/6 minus 120. Now I could have worked the problem just like that and used 120 as my denominator, but I'm not going to do that because I'm going to reduce it to make it easier so that the numbers that I deal with are smaller. So I can divide both of these by 10 real quickly and get 1/12. So 10 1/20 is the same thing as 1/12. So 1/6 minus 1/12. So my denominator would be 12, and this one is the same, but this one I have a 6, so I'm going to be multiplying by 2. So then 2 times 1 is 2, so 2/12 minus 1/12 would be 2 minus 1 is 1 over 12. Okay, Next page. Okay, in this one I have 1/4 plus negative 3/4. That's the same thing as 1/4 minus 3/4, or a positive 1/4 and a negative 3/4. So just remember, it's really this right here, 1 minus 3 over 4. So 1 minus 3, the signs are different, subtracting get 2, big number's negative. So I get negative 2/4. But it's not in lowest terms, so I have to divide both by 2, and I get negative 1/2. Now, on the next one, I'm going to do this division first. Okay? 12. I could have made the denominator of 2. It would have been fine. But let's go ahead and divide this because it divides evenly. 12 divided by 2 is 6. So I have negative 6, and negative 6 is negative 12. In other words, signs are the same, so I add. Now, on the next one, I'm going to write this out on paper so you see. We've got 0.3, we've got 0.235, and we've got 0.1786. So this is 1,786 ten-thousandths, 235 thousandths, and 3/10. Okay, we need to know which one's the largest. So what I'm going to do is, the first thing you always need to do is make them all have the same number of places, and you can put as many zeros on as you want to the right of the decimal without changing the value. So I'll put a 0 here. We've got 4 here, so we need 4 here, we need 4 here, because I had to begin with that 3/10, just so you see here. 0.3, 3/10 is what I had. So that would be 3 over 10 as a fraction, and 3,000 ten-thousandths. So then that would reduce to 3/10. So no matter how many zeros here, it's always going to reduce back to the same thing. Now, once you make them have the same number of places, then you can ignore this. Now, these had a 0 in front of them, and you always are going to look to see that they have the same number in front, because obviously if this one had 1 in front, it would be the largest, okay, because the rest of them wouldn't have a whole number value. But if it's all that way, all I have to do is think of, now that they have the same place, what do when I look at all 3 of these numbers, which one is the largest now? And it's 3,000. 3,000. So that 0.3 or 3/10 is the largest number in the group. Okay. The next one. Now, the next one is a matter of taking a look at and thinking about realistically what makes sense here. You want to name the largest in the fractions. All right, now let's think about this a minute. I've got a pizza, and it's divided in 7 pieces, a pizza divided in 11 pieces, a pizza divided in 13 pieces. Ignore the top and just think about the bottom, which is the largest size of piece. And I would rather have a pizza divided by 7 pieces than one that was divided by 11 if I was going to only get one piece, because this would be the largest pieces. Now, if I have 3 of the largest pieces, they're going to be larger than all the others. So by common sense, you don't have to do anything. You can just say, since they all have the same numerator, 3 of the largest would make 3/7 the largest. Now, the other thing you might want to look at and think about would be 1/3, 1/4, 1/5. Okay, it's the same concept. They all have 1 on the top. So had you rather have one piece of a pizza divided in 3 pieces, 4 pieces, or 5, this would be the largest. Okay, so the comparison that you can do that with can be any number. They can be 2s, they can be 3s, they can be 4s, but think about what the pieces mean. You always want the smallest number to have the largest size piece. Okay, now the next one is 7.5 plus 4 minus 2.97. So the first thing we're going to do, 4 is the same thing as 4.0. So we always line up our decimal points when we're doing addition, subtraction with decimals. So then I add and I get 11.5. Now to that I'm going to subtract, or from that I'm going to subtract 2.97. But if I only have a 5 there, I don't have anything to subtract the 7 from. Now remember up here when we were doing name the largest and we added those zeros, we can do the same thing here. So I can add a 0. Then I can subtract, and my answer would be 8.53. Big number's positive. Okay, in multiplication, we don't line up our decimals. We multiply as normal. 7 times 2 is 14, carry your 1. 8 times 7 is 56, and 1 is 57, carry your 5. 3 times 7 is 21, and 5 is 26. Okay, now I go to my next row. I put a 0 down because the 4 is over in tens place. So then 4 times 2 is 8. 4 times 8 is 32. Put down your 3, carry your, put down your 2, carry your 3. 4 times 3 is 12, plus 3 is 15. Now, I go ahead and add. 4 plus 0 is 4, 7 and 8 is 15, carry your 1, 6 and 1 is 7 and 2 is 9, 5 and 2 is 7, bring down your 1. Now, to determine where the decimal point goes, I count from the right up here. 1, 2 places, and 1 place make a total of 3 places. So then I go to my number at the bottom, start to the right, go 1, 2, 3, and that's where your decimal goes. So it's 17.954, or 17 and 954 thousandths. Okay, now let's do division. All right, I'm going to do this one by longhand, and then we'll go back there because you really probably need to see the process here. Okay, so the problem started out 12 divided by 0.62. Okay, so the first thing that has to happen is this decimal point has to be next to the division sign. So it goes 2 places. My decimal goes here, and then I have to move it the same number of places that I moved this one. Now it's no longer there. It ends up here. And then I'm going to go right up above it and put the decimal there in my answer. And I have to hold zeros here because there has to be place to hold, a way to hold the place to make sure that I've got my zeros accounted for in moving my decimal. Alright, now 62 won't go into 1. It won't go into 12, but it will go into 120 one time. So then 1 times 62 is 62. Okay, then I subtract and get 58. And I bring down my 0. So 62 into 580 goes 9 times. Then 9 times 62 would be 558. And then I subtract and get 22. Now, it's not divided out evenly, so I can add as many zeros to the right of this decimal point as I want to add. So I'm going to put 2 up there. So then I'm going to bring that 0 down. 62 into 220 goes 3 times. And I always put my number above the 0 or above the place that I'm using. So if it happened to go 0 times in here, we don't leave it blank or put the number above it. We put a 0 above it to make sure the place is always held. Alright, so 3 times 62 is 186. And then subtract and get 34. And then I'm going to bring down my last 0 that I wrote. So 62 into 340 goes 5 times. And 5 times 62 is 310. So subtract and get 30. Now I could add another 0 and keep bringing it down. It's not going to divide out evenly. Typically on a test like this, it would say, if it does not divide out evenly, round to the nearest whatever. So let's use rounding rules and do that. So we have 19.35. Let's say it said round to the nearest 10. So here's what I do. If it says the nearest tenth, then I underline the place that needs to be my last. As a process, I put a line. I look to the right of the line. Is this number 5 or more? If it is, then I add 1 to the number on the other side, so that I really then have 3 plus 1 is 4, 19.4, and then everything that's to the right of that line, no matter how many numbers there, all become zeros. Okay? So rounded to the nearest tenth would be 19.4 or 19.4. Alright? Now, the next problem is a percent problem. And I'm going to work and show you my trick. Alright. Typically, students have a problem deciding, do I multiply or divide? And they typically get the problem wrong, not because they can't do the math, but because they do the wrong operation. So I have a foolproof method, and it is as follows. Always begin by putting the percent over 100, because that's the part of 100 that you have. Then whatever in the statement follows the word of goes on the bottom. This represents the total amount, or 100%. Okay, so that's why it's a proportion. So everything that's on the bottom is what's recognized as 100%. Now, the top part that's on the top will be any number left in the problem, or the part. Okay, because the percent of 100 is part. Alright, so this problem says, what number is 14.5% of 75? Now let's do my rule here. So, percent over 100, 14.5 over 100. Okay, what follows the word of? 75 goes on the bottom. What number is left? There's not one. It's what? So that's our x. Okay, then when we have a proportion, the product of the means equal the product of the extremes, which means multiply the parts, do the cross multiplication thing. So then you would get 14.5 times 75 equals 100x, and then divide by 100. So that x equals 14.5 times 75, which would be 1087.5 over 100, and dividing by 100 moves the decimal 2 places, so it's 10.875. Now, here's the trick that I tell students. When you cross multiply, do your cross. Look at the two numbers at the end that you know. In other words, I know both of these. So simply write them down. 14.5 times 75. Okay? Or I'll go ahead and put it in parentheses so it's easier to see, so it's not confused as a decimal. And then the number that's left by itself, in other words, at the other end of that one is x. I don't know what it is. So the one that's left by itself is what I divide. So my procedure then would be to do this. I multiply that times that and then divide by 100. It works every time. Okay, and that's exactly what we got. It was still 10.875. Okay, I'm going to do another one using my same process. Okay, and it is, what percent of 34 is 10.5? Okay, So, what percent? I don't know. So, percent over 100, so it's x. If you don't know it, it's the x. Oh. Sorry, my computer timed out on me because I hadn't wiggled it. So, what percent of 34 is 10.5? So what is the x? So what percent? What follows the word of is 34. Now, the number left in the problem is 10.5. So I cross the two I know. So 100 times 10.5. Okay, so when I multiply that, then I divide by 34. And when I do all that, I end up with 30.882, and it goes on and on. It doesn't divide out evenly. So it asks what percent. So typically when you see a percentage, it might be 52.8%. Sometimes it might be 52.89. So I'm going to round to the nearest tenth so that 30 point, this is 5 or more, so I add 1 here and make that 9, and all of that goes away. So it's 30.9%. Okay, and the last type of problem that I have is 96 is what percent, oh no, sorry, 92 is 32, 96 rather, is 32% of what? Okay, so percent over 100, 32 over 100. What follows the word of? What? What's left? Cross multiply, and I have 96 times 100 divided by 32, which equals 300. Now, okay, now let's go on to solving for x here. Okay, now this is 5 minus 3x equals 14. I'm going to zoom in just a little bit on this one. Okay, so I'm going to subtract 5 from both sides, and then this one goes away, and I'm left with negative 3x equals 9. Divide both sides by the number, always with the x. It needs to cancel because negative 3 over negative 3 is 1. Then 9 divided by negative 3 is negative 3. Okay, the next problem. Now, got to pay attention here because this says find all x values that solve the equation. Okay, so this is multiplied together. So it's already factored. So what you would remember is that this looks like factors. So my answer is actually going to be a quadratic, like x squared plus 2x minus 9. This little squared term, that's not what it is, but this squared term here indicates that there are two answers. Okay, so the factoring work is already done. There's nothing to do about that. You just have to know to set each factor equal to 0. So x minus 6 is 0, x plus 4 is 0. Then I add 6 to both sides, so x is 6. I subtract 4 from both sides, so x is negative 4. So two answers make this correct. And think about that, because 6 minus 6 is 0, so 0 times that is 0, and that's true. All right, now, the one on the right. Got to be careful about multiplying and dividing and finding common denominators and things like that. And typically, anytime we have a fraction, which would be what this would be considered here, because this is a 5 in the denominator. So I'm going to work these problems just like I work these. I'm going to cross multiply. Okay? So if I cross multiply here, then I get 5x. And see, this was just plain x, so I can always put anything over 1. So then 5 times x is 5x, and then 1 times this whole quantity. So you have to put that in parentheses, and then 1 times anything is just what you start out with. So now I need to move this x over here to join this one. So it's added here, or it's positive, so I make it negative or subtractive. So 4x minus 4x is 0. And then 5x minus 4x is 1x, or just plain x. Bring down my negative 3, so x is negative 3. Alright, now let's look at the one on this other one. Now, this one could be problematic, okay? Anytime you have an x in the denominator, you always have to look at, is there a way for that answer to end up and be, like if you had on the bottom here, let's say you had x minus 2, and let's say you work it out and the answer says, let's say you've solved this whole big equation and it works out that x equals 2. But if you were to put in x equals 2 here, 2 minus 2 is 0, so that would make this whole denominator 0. So 2 could not be an answer to that problem, because there's no way that you can ever work a problem and have 0 as a denominator. So 2 wouldn't be a solution, even though it actually you solved the problem and it worked out. You're probably going to have another one in that instance, so you can sometimes eliminate those. But if there happen to be an x in the denominator, you always have to make sure that you're dealing with working and making sure that your denominator's not 0. Let's say you worked a problem out and it just got 0. X equals 0 was your answer. 0 couldn't be an answer because that would make a denominator 0, which is undefined, and so in that case your answer would actually be no solution. Now, in this case though, I'm doing the cross multiply thing again. So 7 times x is 7x, 6 times 3 is 18. Then I divide both sides by 7, and x is 18 over 7, and that's fine. You don't have to go on and do any more, but you could actually go ahead and divide it, and 7 into 18 goes 2, and 2 times 7 is 14, so 14 minus 18 gives you 4/7. But you don't have to do this. You can leave it here. Just make sure, if it is an improper fraction, just make sure that it's in lowest terms. Now, I'm going to do the other way here. I can find a common denominator like we did with all the other fractions. It would be 3 times x is 3x. Then the 3 is missing here. So 3 times 6 is 18. And here, the x is missing, so x times 7 is 7x. So then I have to multiply by my 3x to get rid of it. And then I'm left with still the same thing up here. It's just switched to the opposite side, but that's okay. 18 divided by 7 is still your answer. Now, the very last problem that I have has a distributive sign here. It has a negative, a minus 3x minus 4. That I think is probably easier to see. So that's like a negative 1 times negative 3 makes that a positive 3x. And a negative 1 times negative 4 makes that a positive 4. In other words, I'm distributing my negative to what's inside. So basically, I'm changing all the signs of everything inside the parentheses. So then I'm left with 5x outside plus 3x plus 4 because I changed those signs. And once I do that, then this right here, it becomes a positive. All right. Now, so I combine both my x's, so 5 and 3 is 8. They're on the same side, so you just combine. Plus 4 equals 0. Then I move my 4 over, so I have to subtract it from both sides, so that 8x equals negative 4. Divide both sides by 8, and x is negative 4/8. Okay? But that's not in lowest terms. I can divide both of these by 4, I'm sorry. And 4 divided by 4 is 1. 8 divided by 4 is 2. it's still a negative, but it's negative 1/2. Okay, I think that's it. Yes, that's all the problems. And I will take and scan this and actually email the document. I'll post the document to Blackboard and add this video to it as well.